Hello, Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today we're going to take a look at an antenna from Alpha Antennas. I got this from them at Dayton, and just to be very clear about this, they gave it to me, so I've got something to look at here. This is a vertical. Now, it's supposed to be a portable MIL 2.0 antenna for 6 through 80 meters. It consists of several parts. It sits atop a tripod, this tripod here, it's aluminum, and it has a coil and then an element going up which is not adjusted to tune to different bands. And then also attached to that spot up there is a 25-foot wire that's supposed to be for NVIS. And then also there's a little bit of a ground connection, and that's about it to the antenna. Now, we tried a few things to check out the antenna after we're carefully sure that we had put it up correctly, as you see in this photo here. Now let's turn to the testing of this antenna. The test antenna is the Alpha Antenna MIL 2.0 FMJ. It's set up per the instruction book. So it's got one ground connection and it's got one 25-foot long piece of wire that is the NVIS piece of it. The reference antenna that we use for comparison is my full-size vertical with numerous radials. It's the Step IR Big IR. Now, the test equipment that we use is the Nano VNA for the SWR, a software-defined radio called the SDR Duo, using the SDR Connect software, which is their latest new software. It's two receivers in one box, so you can compare antennas directly for receiving. The other thing that we did for the transmitter testing was the reverse beacon network using my ICOM IC7300 at 100 watts CW for the transmitting tests. This chart right here comes from the Nano VNA, and it is very interesting and almost in some ways a little hard to believe. You'll note that across the band from 3.5 megahertz all the way up to 30 megahertz, the SWR is way less than 2 to 1. So you have no problem connecting any transmitter to it on any frequency, really. Now, this is much better than the situation shown in the manual itself, which shows some higher SWRs, and I was quite surprised to get this result. Normally, I would not expect a result like this unless there were serious resistive losses in the antenna itself. In other words, the antenna's ohmic resistance being pretty significant. But I don't know. I can't find any reason that would be the case, and the antenna does work, as we'll see. But SWR is not a problem. Now, I used the dual radio, the SDR Duo, using the new SDR Connect. And this software can be used to run two receivers at once. So I set up the receivers identically on 14075 on both sides, which means it puts it in the middle of the FT8 band. I kind of wanted that because for several seconds in a row, you have nearly identical amounts of energy coming out. So I'm going to just focus in on the part here that shows the radios and show you three examples. This first example shows that the reference antenna has a sensitivity here of minus 77.6 dBm. More important, the signal-to-noise ratio is 22.2 dB. And that means from the top of the signal down to the noise level on the floor, 22.2 dB. Whereas on the bottom, which is the test antenna, we have minus 87.6 dBm. So notice that the sensitivity of the antenna is about exactly 10 dB less. The signal-to-noise ratio is 18.1 dB. The signal-to-noise ratio is important because how far the signal sticks out of the noise determines how easy it is for the receiver to pick out that particular signal. The actual depth here, the 77 versus 87, is not as important because all receivers have enough gain that you can just turn this up. Now, a minus 77.6 to minus 87.6 is 10 dB. That's less than 2 S units. What's important here is the 4 dB difference in gain. Again, less than an S unit. The next example we have, we'll just look at the signal-to-noise ratio. Here's 25.7 to 19.1, so about 6 dB. That's a full S unit, meaning that when you receive your signal, it will be about an S unit down. And our final example here, just a little bit more than an S unit on here, shows in all cases that the ability of the antenna to hear is about 10 dB down. Now let's look at some transmit tests. This is using the reverse beacon network, transmitting with 100 watts CW on the frequencies shown. Now the only way this is important is if you can find comparisons. The light blue here is the antenna under test. The reference antenna is the step IR, big IR. Okay, now there are two overlaps. VE3EID right here, you'll see that it receives 5 dB better on the reference antenna than it does on the antenna under test. So that is in line with the receiving tests. Now there's also one here where K7EK received a little bit better, 4 dB better, less than an S unit better than the reference antenna. So this happens. Signals do funny things in funny different directions. So the testing summary here is that the MIL 2.0-FMJ is definitely a compromise antenna. It's about 5 dB, meaning an S unit or so, down on both transmit and receive. It has remarkably good SWR. I say it is so good that I remark on it. This is very unusually good SWR. I did calibrate the VNA before I checked it out. Also, this correlates with some other checks that we did just using a regular S meter with my transmitter. The antenna is easy to set up. There are only a few pieces. It uses Alpha Antenna's robust tripod. By robust, I mean robust. It has a small total footprint. The longest piece on it is a 25-foot piece of wire that's used for the NVIS capabilities. I have no way of testing NVIS by itself, so I will simply have to take their word for it. It is a compromise antenna. The compromise in this case is about an S unit or a little less down on both transmit and receive signal-to-noise ratio. There is no compromise on bandwidth. So, if you would like a little antenna that's easy to set up, you can try this one. You might look at some of the other antennas out there also. There are a number working in this same space. And as far as where you can get it direct from Alpha Antenna, and it's alphaantenna.com. And we'll show here is the price for that antenna, the one that I tested. So, where do we come? I think there are some other antennas I would like better, but this does cover 80 meters and is designed to be used for NVIS. So there you have it. Talk to other people who have them, see what you like, and I've just tried to present to you what I've learned. Again, my thanks for the gift of this antenna from Alpha Antennas, and until we next meet, 73.